Okay, I think I am live. Hi guys, hello and welcome to today's Plumbers of Data Science episode where we are talking about Hadoop and the many problems or issues that are here with Hadoop. Before we start, if you're new here on this channel, we are talking a lot about data engineering, basically the plumbing of data science with tools like Hadoop, Kafka, Spark, and so on and so on. If you haven't seen my cookbook, I have made, or I'm currently working on a cookbook that is free on GitHub. I'm going to put the link below in the description. That has many cool things from where's the okay, I need to recompile this version. Table of contents missing. This is a huge document with a lot of links. Check it out. Link is in the description. Hi guys. Hi Sebastian, Nick. Hi Sally. Hi. Great to have you here, guys. Como is also here. Hi. So today's stream is not a coding stream. Today I have something regarding Hadoop. As I mentioned earlier, there was a lot of discussions about Hadoop in my last video about Hadoop. And so I thought this stream is some issue all about issues with Hadoop. Another thing that I quickly want to show that is very cool, and I didn't know this on my GitHub for the cookbook. I cleaned it up a lot. There was somebody, I forgot the name, added an issue, and that issue said basically add a git ignore file. So all the other files that are created when you compile the PDF are not included in the actual cookbook, and that totally makes sense. And great. So okay, now that you guys are here, let's get into it. One more thing before we start, and I want to have an honest answer from you guys. The coding stuff. The last, by the way, I'm sorry for the last stream that I had to abort so quickly. That's when you have kids, but that's normal. Do you like to see this type of coding in the future? Because I'm not 100% sure if you guys want to see me struggle through the whole thing, and or if you would like to have a more prepared stream where we quickly go over the points. And I'm not 100% sure what to do. For me, the prepared stuff would be a bit harder because I don't have that much time. The upside would be that you get the answers very quickly, but you don't see the way how we got there. I'm access to everything. So quickly write in the chat what you think. I'm not 100% sure. I think Dragonfly says coding live can be okay thing provided some practice has been carried out behind the scenes before delivering the content. That could also be some kind of a test to first test the stuff out and then make the stream. This means though that the frequency will get lower because I need more time preparing the stuff. But on the other hand, I think it's quite boring for you to struggle with me through an hour of setting up the networking in a Docker container. maybe another thing would be struggle through. If you don't have the time, I make another video with cuts. I don't know. Give me just your opinion. So in the meantime, let's get right in here. We are 12 people. Awesome. And so I have the things from Hadoop. I have it in it's not ordered, so we can go over it and quickly look at the chat. Industry use case with coding part. Live to inspire, that can be hard because you don't get you don't really see what they're doing. The struggle makes it interactive. We had some really cool discussions that really helped us along, and I'm putting the code hints into the cookbook as well. How machine learning on Hadoop platform works, that's not my type. Like with how is that called? Let's not get bogged down into Hadoop. So everything that is wrong with Hadoop. First thing that always comes to mind is it's super complex. So you have many tools within the Hadoop, let's call it ecosystem. You have the core things like HDFS, MapReduce, and Yarn, and then you have the other components like Spark, Hive, Kafka. What do I have here? Kudu, Impala, Scoop, Hue, HBase. So there are the many tools that can live on a HDF or on a Hadoop platform, and it's super complicated. And because you need lots, that's the second part, you need because of that variety, you need lots of experiences in many of these services, if not all, because people are using many of them, and that is an issue, that a very big issue, that you need experts for this. It's not that you install it and it runs and it's super easy to configure. It's so many systems. It's very hard to actually have everything down, or can do everything. Next says, ideas very nice. Starting up containers with big data stuff and make it work together on simple examples. Very useful point. I thought that was what we were trying to do already. But maybe I understand you wrong. The next thing, lots of experience. I'm just checking my notes that I've done throughout the day. Another thing that is version mismatching. So I had issues where you're running, you want to run Spark 2 and you're using Uzi, and the version of Uzi does not work with Spark 2 because you're in a older deployment, and then this thing doesn't work. So you need to run on console the jobs, because with Spark 1 it works, with Spark 2 it doesn't, and you need to read up on this stuff, and then you can find it. Another thing that I had a long time ago was the version mismatches between something like a key value store, HBase, because it runs on Hadoop, that I tried out, and with Spark. At some point, when you were going up the versions on the vendor distributions, with Spark they changed the logging, and they moved some classes from the logging to another folder. And there were built in Spark, there are ways to access HBase. And if you don't know it, you try to access HBase with these classes, which make it very easy. But then it doesn't work. You get errors because these classes use the old, or want to use the old paths in Spark, or they're looking for the logging in the wrong area, and then it doesn't work, and you need to Google the stuff and find out that it's a version mismatch between these two and stuff like this. I had many times, and this is super annoying. Another thing, community editions, like the one from Cloudera or Hortonworks, they're nice and they're super cool for testing out this stuff, but they're for production not so good, because some features for the monitoring are missing, some configuration stuff is missing, and you don't have support from the vendor, and you are also missing rolling updates. For instance, on Cloudera, if you're on the community edition, you don't have rolling updates. So let's say you're on a cluster with 20 nodes and you want to do updates. You need to shut the whole thing down, do the updates, and then start it up again. And when you have rolling updates, you can do every node by itself, and you don't have downtime, basically. And stuff like this is community editions, as I said, are very nice for beginning. But if you really want to move to a production environment, you need to pay. You need to pay for the professional edition, or the how is that called? For the licensed edition. I don't know if you guys, have you made some experience with community editions? I don't know. It's my, yeah. Then we are getting into the costs. So I should have put this first, but as I said, this is a non-ordered. Initial investments are usually the problem with Spark. Not Spark, with Hadoop and Spark and everything that runs on the Hadoop platform. So when you compare it to a simple solution, like a SQL database or something, you cannot start with one server. You cannot start with two servers. So usually for instance, what Cloudera, they suggest, and I have read this many years ago, and I would need to look it up to be 100% sure. But what you really need are two nodes, two name nodes, if you're running this on either a primary and a secondary, or if you're doing high availability, those are two name nodes. And so you need two name nodes who basically only do the management. They are not doing the storage. Then you need storage, and for storage you need I think it was at least 5 data nodes, because usually you're putting in data, and you have a replication factor of 2 or 3, and so everything needs to be a bit bigger because all the replication, and this will get expensive. This will get expensive. There is no okay, Nick says at least 3 data nodes. Okay, so you need at least 5 servers, and then you need it is good if you have a management server for the distributions, or for the monitoring and so on. So you're already at 6 servers, and this thing will cost you, and then you're going to set up bigger servers, and yeah. If you're doing a lot with Spark and you need a lot of cores, then the servers will not be so small, because a few years ago they said for Hadoop you can use commodity hardware. That gave people the idea that you don't need high, or you don't need good hardware, just simple desktop hardware, which that doesn't work, especially when you use stuff like Kafka and Spark. And processing on it, then you need lots of cores, you need lots of memory, and then you need good servers. Nick says depends on replication factor. It's also it's also how you're querying the data. If you want to on a system like Hadoop, you need to use parallel processing basically. And if you only have 3 servers, that how much parallel processing can you do there? So you need, because the data is getting stored on the servers, and the more servers you have, the more it gets distributed over the network, and with it's faster to process, and you have more security for data nodes going down and so on. So 3 is, you cannot do a lot with 3 data nodes. This is it's for for beginners. Depends on replication. I've read this. So Mark said every distributed DB will need multiple machines. Yeah, of course, that's absolutely true. Run Hadoop on EMR spot instance, and your cost will be a fraction of what you spend with bare metal or reserved instances. In the case you can use anything, Kafka has replication, so machines can drop out. Yeah. Cheap machines are fine for Hadoop. No, cheap machines are not fine for Hadoop, because, as I said, if you want to do processing, you need lots of cores. And if you want to use Spark and do Spark heavy memory heavy applications, which are very, very fast memory heavy, so then you need good machines. I haven't run it on Elastic MapReduce spot instances, so I cannot say something about this. Of course, or I'm guessing this is cheaper than reserved instances. Another thing, but 20. Mark says 32 cores and 64 gigabytes of RAM. 64 gigabytes of RAM is more or less nothing. If in a Spark application, I would easily, or if you're running Spark, I would easily go for 265 gigs or 512 gigs. So this stuff is getting higher. Initial investment is high. Yeah, MapReduce is absolutely. I don't know where you use MapReduce. Most people right now use Spark, so MapReduce is a bit older. If you're using Hive, then you can use MapReduce as a back end for processing the data. But in other ways, the whole I haven't put this in, the whole as they once had machine learning on top of Hadoop with, how is that machine learning called? How is that called? Mahout. I don't know who uses that. Nobody uses that. So, yeah. Nick says when you talk about fast analytics on fast data, cheap machines is a wrong way, unfortunately. Yeah, that's true. That's absolutely true. Then so MapReduce, more or less useless. Except for Hive. I think Hive it's still a okay use case. One thing though with MapReduce, the idea behind MapReduce, how MapReduce works for the learner, that is still a good idea to figure this out and to learn this stuff, because this is going to follow you, for instance, to Spark, where you again have map and reduce functions, and you can use this stuff there. So as a as a basic thing. Yeah. Mahout keeps improving, by the way. Yeah, but shall I bring up Google Trends again? I'm guessing. Let's quickly bring this up. I'm guessing that compared to the interest of people in Spark, it's basically nothing. No, let's not bring this up right now. So, where did my note go? Where is my note go? Here. Great. Where is it? Here it is. Okay. Where was I? MapReduce. Yeah. The another thing is, so the basic thing for Hadoop is basically, as I said, is HDFS, the file system, the storage is MapReduce for processing, and Yarn for managing the resources. And now you can have Spark and Kafka on top of it. And if you're going to something like a Hortonworks distribution or a Cloudera, I'm familiar with Cloudera, and with Cloudera, in the normal Cloudera distribution, Spark and Kafka are not in the standard CDH distribution. You have to initially or additionally load it as parcels on the system, and this is also where you sometimes get these mismatches of versions, which is super annoying again. And so they more or less they add more and more stuff to it, and unfortunately this stuff is all bolted on. This is not really really in there. I'm as Mark said, there maybe a few apps need MapReduce, but there are plenty of existing apps that they have made good use of it. No doubt. It's but for future, and especially for the data scientists that are using that are doing machine learning, this stuff is I would not recommend. Mark said, why did you choose Cloudera when there are so many better options out there? So which are the better options? Hortonworks or MapR? By the way, I cannot really tell you why I'm having experience with Cloudera and so on. So I cannot go into details. So what did I also have here? If you're using, for instance, HBase can be super annoying, and that's because of key value of the structure of a key value store. And with key value stores, the indexing, you don't have indexing like a SQL database or with HBase especially, and it's basically based on the row key, and the row key is getting sorted, and with that, the problem that always arrives is, what do you want? Do you want fast write speed? And then if you want to have fast write speed, basically the keys need to be some kind of randomized, so they get distributed on as many servers as possible. Or do you want to have read speed? And if you want to have read speed, the things you query need to be as closely together. And so this is a huge huge problem, that you don't really can have both high read and high write speeds. This is always annoying, and with HBase, the region hotspotting is. Nix's CDH6 has Spark and Kafka under the hood by default. Yeah, they made some progress. But not everybody. I'm guessing not everybody is running CDH6. Yeah. This. I mean, Mark makes some really good points here. You need to look at the cloud vendors, and if you're on a cloud installation, you have a lot of options, and so it's even harder to figure out which one to use. And Hortonworks is a very interesting provider for this stuff. They're more or less now Cloudera, but as we mentioned in the last one, the integration of this stuff doesn't really seem to go that well. Yeah, I cannot speak how much functionality is removed from Spark in Cloudera. I once had some, or on so I a few years I have visited in Berlin. There's a how's that? It's not a meeting. It's a, how's that called? Not a convention. So it's where, how is that called? It's called Big Data Minds. I haven't joined it last year. It's German, and there are coming a lot of people together and speak about this stuff. And I don't know. Let me just check something. Yeah. So, and there I had some discussions with MapR, and yeah, that didn't really turn out that good. So I'm not a huge fan of MapR, but that's only me. I think one thing that I have seen about MapR is they have a very easy access to HDFS, so because it's like you can mount it as a drive, which I find very interesting. Oh man, I'm clicking stuff around here wrongly. Just let me. Yeah. Another thing, Hive with Tableau, you need a good amount of servers and you need a lot of power. Yeah, you cannot use your 3 servers and think about running on scale, running a service throughout Hive, through Hive, that you can access data with Tableau. That's not going to happen. You need some power. Region hotspotting also mentioned. Yeah, another thing that is tied in with the distribution stuff. So now you could say, okay, I don't want to have something like Cloudera or Hortonworks or MapR, and I want to set up my own solution of Hadoop. And people may think this, because it's open source, I mean, why not? This is super complicated because there are so many services and the configuration is difficult, and I would not want to do this without helper of some monitoring software or configuration software. This is some management tools. I think this is not so much fun to do. And yeah, also the monitoring. If you don't have a distribution from a vendor, monitoring, I think, is not fun to set up and find a way of monitoring a cluster in a good way. Yeah. Let's just check. Tableau and Presto with Hive only for metadata. Yeah, for metadata. But sometimes you want to look into detailed data, and then you need power. Yeah, MapReduce should open their source, their file system, as Tim Spun said. Okay, I don't know. Makes sense. Tim is very, very clever. Yeah, MapReduce is, as we've seen in the on what was the last podcast? 89 or something, where we talked about Hadoop. That's a bit, yeah, they are in a bit of trouble, and they should open source this stuff. Yeah, I have made for basically everything I do, and this is why I also made the cookbook public. It's very interesting when you open source stuff, and it's interesting, it's good, people are interested in, and especially I think for software where people can improve on it and work on it, like with Spark. This gives a lot of push to a project. Like with the cookbook, when I had the cookbook locked down on my Patreon, basically nobody saw it, and yeah, this thing now has 1,300 stars on GitHub and 128 watchers. So as you can see, this stuff makes super sense, and open source stuff, if you're good, you can make a lot of money. But this is a philosophy from a company. Mark says Presto has some of the best SQL support. If you need row level, I can do that. Whoever wrote Hive forgot a audit long ago where Presto has been making huge improvements. I don't know. I have not that many, or I haven't no experience with Presto. I only have read this stuff. Never used this stuff really. Yeah, Hive is a bit. It might be a bit antiquated. Let's call it antiquated. Yeah. I don't know how, but the idea. I mean, the idea is very good. That you can make from basically unstructured data or data that is stored in a file form. You can format it back to SQL and then query it like a SQL database. That's super interesting. One thing I totally missed here. Did I miss this? Is the small files problem? Let me just check my notes. I'm basically through. I totally missed this. A huge problem. A huge problem with that I found with Hadoop, and that people are neglecting it, and is the small files problem. That it gets better now that the name nodes are getting stronger, but every file or every block that is written on HDFS has some metadata, and basically the information about the file and the information where it lies. And so this stuff, the metadata, is stored in the name nodes. And the problem is, if you have a lot of small files, millions of small files, then the name nodes get big, and the let's say the metadata in the name nodes gets big. And this, while working with the cluster, this isn't that much of a problem. The problem comes when you for instance restart stuff, or when you have a failover and the name nodes are failing from one to another, and then the old one that went down needs to go up again. this can take very, very, very long if you have a small files problem. And now you would say, small files, how can I get small files? Where should come these millions of files? As Nick said, when you have fast moving data. So let's say you're having something like a streaming application or many streaming applications that, for instance, post logs into your system, and the logs are flowing into Kafka, and messages get there, and you want to, in a streaming manner, you want to process them and store them. And the problem is, you cannot really do this with HDFS, because every time you try to, it doesn't matter if you try to append something to HDFS or to a file, you're getting these parts files. And with these parts files are more or less need to be stored in the name node. And so if you're, it can get very, very quick if you're creating a lots of messages and you're processing them fast. You can have a lot of files stored in HDFS. So then you're running into these problems. Now, you could say, okay, then let's compact it again, and so that you basically write another Spark job that takes data from a file, from a folder with thousands of files, and then put it somewhere else. And so there are methods. Mark says, put Flume in between Kafka and HDFS. It can roll them up based on time or size. Yeah, so this is what I mean. So you need to put some other things in place so that or you take the data, store it in a key value store, and once a day you extract everything and write it down in a single HDFS file or whatever. So this intention, or this problem that you have so many files, this can arise very, very quickly. And that's I think with cloud solutions like S3 or something, you don't have to think about this stuff. And this is a problem with HDFS that is coming up, that is going to come up. And and Nick says, Mark, isn't that an over engineering? That's stuff you need to do. You need to. It's more or less, it's a workaround. This stuff is a workaround to fix problems with Hadoop, and that's not so much fun. Of course, what you can also do is it depends always how fast you need the streaming data. You need to have access to the streaming data, and you need to have access for the streaming data in your batch shops. So basically, this if you need the for instance, if you need the data only once a day, then you could write this into Kafka, and once an hour you make an extract into HDFS, and then you have hourly folders, hourly files, or redo hours, or if you only need once a week, you can make daily. So you get the idea. Mark has some very interesting insight here with the truncate. You can truncate or append files on the S3, so things like CSV or org isn't possible with S3 alone. This is why HDFS is still around. It's much closer to POSIX systems. I don't know what a POSIX system is. Could be over engineering, he says. I'm sure Confluent has some sort of enterprise method for doing this. Yeah, people are getting workarounds. Ah, okay. Okay. Normally Unix file system, yeah. So, yeah. Sometimes I'm a bit of an idiot. Yeah, another thing that I have questioned here was Kubernetes. I'm not 100% sure how to run this, how to run HDFS or Hadoop on Kubernetes. I think you can Dockerize it, but I don't know how good this stuff works. This is a big question mark for me. I have no experience with this. I'm guessing that this is a problem. Yeah. So I'm more or less through. Let me just quickly check the. I made this post on LinkedIn. Let's see if somebody has an interesting insight here. Kubernetes. Yeah. Kubernetes. Where is it? 20 comments. Why can't I get this? Okay, let's share the desktop. Who are these guys here? So, oops. So Hadoop was the need of the hour when storage was inexpensive. Today cloud storage is cheap, so why distribute spend cycles to bring it all together? Oh man, okay. There are people are already getting in other systems like Snowflake. No idea. So how exactly Snowflake does that? No answer. So yeah, Hadoop was the need of the hour when the cloud services weren't there. But yeah, cloud is the big threat for big data. It's not a threat. I mean it's for Hadoop, but yeah. So maybe one of you guys lived to inspire says any thoughts on product like Snowflake. Maybe you guys have some insight on Snowflake. That would be interesting. MapReduce implementation of Hadoop is a problem. Yeah, it's not easy to update existing records. That's always a problem. I mean, for HBase, you can simply override them. Or on HDFS, this is this interesting. Selling open source frameworks and configuring open source. Yeah, maybe time consuming. Big data distros ease the installation. However, they are not good enough. Oh, I mean, they're quite good. They offer more services. That might be true. Setting up a Hadoop cluster is not cheap, as big data distros claim. Yeah, it's as we said. You need a fair amount of servers, and this stuff isn't. You need good servers if you want to have throughput, and processing power. That word, I don't know. What does that mean? Intricacy. Quality of being. Okay, complicated. Yeah. Which is faster, HDFS or S3? That's a good question. My guess is, yeah, Mark says by 2 times. My guess would be especially if you're running. So S3 is completely virtualized. So you don't really know what's behind it and how the systems are running behind it and how the setup and everything. And if you're, especially if you're on hardware, a hardware cluster with fast drives and good good networking speed and so on, it should be a lot quicker. So Mark says 2 times. That sounds right. Yeah. I mean, I'm guessing it's faster because it's virtualized. So because S3 is virtualized. So I'm guessing, but maybe let me just quickly close something here because somehow my Explorer or my Safari doesn't work 100%. HDFS versus S3 write speed. Let's Google this quickly. They say cost, elasticity, SLA, performance, transactional write, and data integrity. That's a plus for S3. Cost, performance per dollar. Okay, transactional writes. So this has nothing to do with the write speed. Or does it? No, that has nothing to do. Transactions, okay. Let me just quickly go back and check some more. Yeah, I can't find it. Okay, Google. Yeah. What was yeah. The one thing that people still sometimes don't understand. I find this funny. I've made this point many times. People are saying, why don't you go? Why would you use hardware? Why would you use on-premises? Why would you do that? You have the cloud, you have Google Cloud, you have Azure, you have AWS, and many, let's call them niche products. Why would you do that? And the thing is, you will always need hardware, and you will always need on-premises. A very simple use case that everybody can understand. Let's look at, we're in Germany, car manufacturers. They have plants. These plants are huge. Have you seen how huge the plants are? For instance, in the Wolfsburg plant. Let me just show this to you. I've been one time. I've been in the VW plant in Wolfsburg. This thing is crazy. Maps. So the Wolfsburg plant. Let me just find this. Let's go to satellite. You can already see it from here. Let me zoom in here. Okay, this is the plant here. This is the start, and this is the end. So let's make some measure distance from here to the end. It's over 2 kilometers. 2 point. Ah, come on. Why doesn't that work? Measure distance from here. Distance to here. So it's 2.2 kilometers. kilometers to 2.2. It's 1.36 miles. So this a plant like this is immense. It's huge. And do we have 3D here or something? In Germany, the no, there's nothing. I'm just so it's basically here you can see the cars. So this is a car here, and this is the plant. Let's zoom out again. Okay, so Wolfsburg is a huge plant, and here is the second part here. So it's basically 2 layers, or 2 rows of plant. This is even longer. So this ends here. Oh, let's measure the distance from here to here. Or did I measure this already? Yeah. So imagine the data that is getting produced in a plant like this. It's crazy. And the more the Internet of Things is coming along, and the more sensors you put in, the more data is getting generated, and the more data is getting collected, and so on. So this stuff is going through the roof. They even here you can see it's VW a power station. They have their own power station. So the idea to send everything to the cloud that is getting produced in here, how is that possible? That is not possible. So this whole thing, you need on-premises for that. You need on-premises servers for that. You need a on-premises solution, and you are going to end up with something from Cloudera or Hortonworks. Doesn't matter. So yeah, you cannot go for S3 in these cases. Okay. Yeah, Daimler plants are I don't know how fast how big the Daimler plant in Stuttgart is. Should we search for it? Okay, I was just an idiot when using it. Okay, Nick says it's Sindelfing. Yeah, it doesn't matter. I'm not that big into Daimler. So Nick asks, what do you think about creating streams about industrial IoT? So I think more like sensor data. The thing is, so I'm not 100% sure what you mean by streams, by the way, but I'm guessing is getting sensor data in and streaming it and processing it. And I personally, I'm not a huge. People always tell me, yeah, like you say, MQTT, everything, every sensor has MQTT, and you can send the data everywhere, and no, not video streams, and that's very nice on a let's say on a plant level. That really makes sense. But you don't want to send MQTT messages over the internet or something. So at some point, what you need to have is you need to have some sort of a gateway or something that is basically taking the data from that is collected from the or that is from the sensors. Sensors send it to the gateway, and the gateway translates it into some kind of, let's say, API calls or something. So you really need that. You're not going to send MQTT over the network. You're not going to write a remote Kafka producer and produce over the network something into Kafka or something. This is not going to happen. I mean, so yeah, the gateways are more or less, you can buy this stuff. Or you need to buy this stuff, or you do this yourself. But for production, I'm not 100% sure how complicated this is. But there are I mean, guys like Siemens or what's German? What's another? FAG. I'm thinking, and so on. They should have, or Bosch. They have gateways where you can take data in and send it somewhere. The thing is, the connection to a platform. You need to establish the connection to a platform and then basically create the fitting interfaces for that. Either way, so the taking in of the data might be okay, but then you need to send it somewhere. So I'm guessing many have like something like on Azure. How's that called? Azure Edge. How is that called? Azure Edge. IoT Edge. What's that called? IoT Edge. Build the intelligent. No. How is that called? Database of Internet of Things. IoT Hub. Connect, monitor, and manage. So with something, you need basically a gateway that is transmitting data to something like the IoT Hub from Azure, and then you're working further with the data and so on. Give the salespeople at AWS and Azure more time. 5 to 10 years from now, they'll have VW full on the cloud. Yeah, the salespeople, they can do everything. A good salesman. Mark, I have seen the whole stuff that GE has been telling people with their Predicts platform that a engine is measuring this much data in every second, and it's this amount of terabytes and so on, and this needs to be processed and stored. And believe me, these guys are not processing all of this data, and not everything that is measured is recorded or transmitted. A good example for that, we have done, I think it was the case study of NASA. So at NASA, they said or was that CERN? I think it was CERN. At CERN, they said, we are the Large Hadron Collider. We are measuring this much terabyte of data. This thing produces this much terabyte of data. And then when you look at it, they basically established layers, and they are, with each layer, they are compressing or they are throwing away data, and then it ends up with a lot less of data. And so, yeah, this stuff, airplanes create so much data in theory, but I don't think this stuff. They might be windowing this stuff. This is always possible, but if that makes so much sense for processing or for analyzing the data, I don't know. That depends on what you're working on and so on. So yeah. Nick says Russian airplane company S7 is getting around 10 gigabytes of useful data every flight. That makes sense. That makes sense. I mean, it's still a lot, but that is more in the range of data that really makes sense, that you can handle. If you're saying like Mark said, tens of terabytes of telemetry each flight. This is a calculation stuff to brag about the numbers. This stuff that Nick says about 10 gigabytes of useful data, that makes sense. This is a good direction. Yeah. But now this is how many. Let's just make a quick calculation. Frankfurt Airport flights per day. Why didn't it write it? I have no idea. Let me just bring this up. Facts and figures. Facts and figures, Fraport. Aircraft movements. What is this? So they have in 2018 I don't know if this is flights. Let's just do a quick calculation. Is this possible? No, that's not possible. Is it? 512,000. 365 days. 1,014 movements. Oh, that makes sense. This comes close, I guess. So this would be then around 1,000 movements times 10 gigabytes. Terabytes, around 10 terabytes a day. 14 terabytes a day, if I'm correct. So this is in a range that is manageable. And yeah, 14 terabytes a day. So this you can still send this up to the cloud. This is I think at something like a huge airport, this is possible. Yeah. That was easy to explain and easy to check if that is possible. I'm surprised. Yeah, that was interesting. Mark says in May there were 8,800 aircraft flying over UK alone at one point, all producing telemetry. I don't know why the hard drive vendors aren't the richest firms in the world. That's a good point. Yeah. It's this. I mean, this stuff is getting interesting. Because I think Mark makes a good point here. When the amount of data that we are creating and that needs to be stored somehow, we need hard drives for that, and So the sell the sales of hard drives is going to explode. Not only here in Europe or in the US. Let's look at China. So this, because they don't record everything on long storage, says Nick. That's also true. That's true. But what I predict what you're going to see is that people are going, with the prices of storage going down. What people are going to do is they are going to store data longer, and because if you're looking at so we're within data science, right? So data engineering is the plumbing of data science. So basically the data scientist is using this plumbing and using this storage and access of storage to in generally, let's say, make analytics. And what we're definitely see is the trend that machine learning, deep learning, how AI, whatever you want to call it, this is getting bigger and bigger, and people are using this more and more. So how do you refine an algorithm over time with data? And do you then want to throw data away? Maybe not, because you don't know today if an algorithm tomorrow can leverage this old data and use it in the future. So with the prices of storage going down and the sellers of hard drives are getting richer, what you're going to see is that people are going to start using long storage more, and that's a fact. And I'm 100% sure that at some point people are not throwing stuff away. Kaushik asks, can Cloudera survive with their new merge software? The thing with Cloudera surviving, I don't have a doubt that Cloudera is not, or let's frame this right, or so Cloudera is, I don't want to misspell this, so Cloudera is definitely surviving. That's my point of view, because the demand for this software is not going away. Maybe the merger of Hortonworks is not that easy as they thought. Maybe they just wanted to remove one big player from the competition, and they paid for it. And I don't really care for stock prices. I don't have Cloudera stocks, so I don't care. But I'm guessing this is not going to go away, and they are going to survive. Yeah. The unified platform can only improve on the current Cloudera offering. I don't know. I have not read anything about this, the strategy, what they're after with after the merger, where the platform is going. I have no idea. My guess is that they're moving Hortonworks towards Cloudera, and they're bundling their efforts, and they're maybe firing some people. I don't know, but a real roadmap I haven't seen. Mark, I don't know if you have seen one. I don't know. I have no idea. But this stuff is not going to go away. One thing though, I want to show you, and I haven't seen this. I have seen this last week. Last week, a friend showed me this, which is super interesting, and I actually wanted to discuss this in another episode. But while we're at it, let's. And it's this. I don't know if you already know this. Let me share this. Google Anthos. Who has heard of Google Anthos, guys? That would be interesting info. So the thing with Anthos is you want to easily use the cloud, right? So you want to use services based on the cloud, and you want to have the ease of use of tools, of using tools from the cloud. And you don't want to use that much of configuration and setting up the stuff, and you want the flexibility and everything. So what Google offers here, and I find this very interesting. I know this is live, but it's not that. They don't have that many services. So basically, what they are going to do is, like they say here, transform your IT and build apps for the future. Transform your IT, and they are going to. Wasn't here a nicer picture? I've seen a nicer picture. Oh man. View the documentation. So the idea here is you have Dockerized. You want to use Kubernetes, and Google has some images or some Docker containers, and you want to use these Docker containers for on premise with the ease of the store from Google. And what they are offering is that you are basically connected to the cloud with Anthos. And I'm missing this. So, and basically they are running their installation of a Google Kubernetes engine on your servers, on your local hardware. And there was a better image. I don't know if I can find this. And the idea here is basically you have the apps from Google Cloud that you can also use on the Google Cloud, and you can just deploy this on your servers and run it like you're on the cloud with all the Google services. So it's a hybrid and multi-cloud product here, and you're working on your hardware. They set up for you the Kubernetes engine, and they are setting up the way to download the images and run the images, and basically it's a fully managed service. And how is the price list here? They also have a price list, and the price list. So this thing looks, calculators. This looks different than the one I saw. The idea here is with Anthos that maybe where was that? Okay, I'm going to prepare this for you guys. We're going to talk about this in the next stream. The idea is they're installing basically the stuff on site and on your hardware servers, and you can license a amount of CPU cores and then run the containers in your on-premise like it's in the cloud. So this is super interesting. I'm going to get into this more and show this more in detail. Let's just quickly go to the chat, and then I think we're finishing for today. Mark says 2019 will be a bad year for Cloudera. Maybe 2020, but by 2021 they should get a lot of their past mistakes cleaned up. Yeah, this year is not a good year. They're smart people, but they've got too much legacy. I don't know. This might be true. I mean, their CEO quit, and Mike Olson, the co-founder, and basically, what was he? Chief strategy officer. He retired, and so yeah. No, Nick, I would not go for Cloudera stocks. I'm not sure that these stocks are going to go up in the next 2 to 3 years. I don't know. Support your favorite company. Okay. Yeah, guys. Let's talk again. I'm not sure. Hit the like button, please, on this video, so we let the algorithms know that this is a cool stream. If you made it until here and you still like this stuff, please support what you like. Check out my Patreon. You can find this also on my GitHub. There's a support button, and you can become a plumber and send a few bucks. That is going to go into this podcast and the setup and the services I'm using for the podcast and everything. So I'm not getting rich, but it helps keep the lights on and my wife happy. Okay. Good night, guys. And great stream. That was lots of fun. And yeah, thanks, guys. Bye-bye and good night. See you next time.